guys, welcome back to my channel, and today we will discuss the dollar game. So this dollar game uses the concepts of planar graphs, okay? And this is part 3 of the planar graph series. Planar graphs. And this is part 3 of the planar graph series. If you haven't watched the part 1 and part 2, I recommend you to watch those two parts before watching this video, and it will be shown in the I tab above in the discrete maths with a fun way playlist of this channel. Okay, so let's begin. So you will have a network or a graph where the nodes would be the players, and the value of the nodes would be of three types. Either it will be positive and it will be representing a positive amount in their bank balance, okay, positive bank balance, or they will be having a negative value, that means they are in debt, they have to repay someone this much amount, they don't have money, okay, they have credit, they have a debt, they are in debt, okay. And zero means zero amount in their bank balance. So the objective of this game, when you win, is you have to redistribute the money in the network such that all the nodes, they don't have debt, means no negative nodes are present in the network anymore. So you will flow the cash who have more money, surplus money, they can send money to the all the nodes they are connected to, and the objective is to make all the values of the nodes either positive or zero. So objective is redistribute the money, redistribute money such that no debt, no debt node in the whole network, no debt, okay. So let us see one of the sample networks the game can begin with, the players are connected to, okay. I will make one, okay. Oh, this is plus one, okay, this is plus one. All right. So this is the sample board. Okay. Now the rule is that whichever node you pick, suppose you picked this node, then whatever nodes it is connected to, it is connected to these three nodes. So in one move, he can send one, he has to send money, one unit of money to all the three nodes it is connected to. It cannot send like this, like it is sending only to this node I am pointing to. No, it has to send to all the three. So it will become, if it sends plus one plus one plus one to all the three, its value would become -2. Okay. So we have to find if we can win the game or not. We can make send money in such a way that no nodes have a negative or debt value. Okay. Either they are positive or they are zero. Zero is also valid. Okay. So let us see, without any observations, in a layman way, how we can play and win this move. Okay. So what I am thinking is, see here there is a -1 node. Okay, this is the initial one. There is a -1 node. Okay. So in order to make this positive or zero, what I can do, it is whatever node it is connected to, it is, this is negative, this is also in debt. So someone in debt, if he sends money, then he will be more debt. So what I'll do, this node is has a positive value, so I will send, in the first move, send money from here to here. Okay. No, but you know the rules, it has to send, if this plus one is sending money, then it has to send to all the nodes, right? So it has to send to all the nodes like this. But that that will make this node negative. I don't want that. Let's see any other moves uh, which is valid. Okay, or we can do, what we can do is this plus 1 and this plus 1, these two will send money to this. So what will happen, it will have plus 3. Now this node will not become negative. So what we do is, in the first move, we are sending from this node to all the nodes it is connected to. So the configuration becomes, okay, this becomes plus 2, and this becomes 0, and this becomes plus 1. Now what we do is, now in the third move, this is also plus 1, right? I don't want this node to become negative. So I will send money from here to here. Okay. We will move to the next page. Okay. So we will have 0, -1. We will have -1. We will have 3 over here. We will have 0 and 0. Okay. Now look, this node, if it sends money to all the three nodes it is connected to, then this node will not become negative. So that was the goal, right? This was the second move. Now third move. In the third move, what we are doing, we are sending node money from this node to all the three nodes. Okay. So 0, -1. Oh, this will become, it is sending 1 unit of money, right? +1, +1, +1. So this will become 0. Sorry. This will become 0. Okay. This will become 0. This will become 1. This will become 1. And this is still -1, right? Now, okay. Now what we can do is, now we have to make this node positive. For that, we have to make this node positive, and for making this node positive, again I have to make this node positive. So what we will do, again from these two nodes, we will send 1 unit to this node. Okay, in the fourth and fifth node. Fourth and fifth move. Okay, so I am combining the fourth and fifth moves. Okay, 4 plus 5. Okay, after that, what will be the status of our board? 0. This will be -1. This would be 0. This would be 2. This would be 0. This would be 0. Okay. Now, in two more moves, what we will do? +1 we will send on this node. Okay. So this will be 6 plus 7th move. I'm writing it together to save time. 0, -1. This will become 2. This will become 0. This will become 0. This will become 0. Okay. Now what we can do? From this node, send to all the nodes it is connected to, right? Yes. So that would be +1, +1. It will not become negative. So eighth move would be, I'm writing in the next. Okay. Oh, let us see. Okay. So this will become 1, 0, 1, 0. Then it will be 0. Then 0, 0, 0. Okay. 0, 0, 0. So yes, we won the game. So how many moves did we use? So this is the eighth move. In 8 moves, we made this redistributed the flow amount, the extra money among the nodes, such that nobody is in debt in the network now. Everybody has a positive bank balance or at least 0. So Now the question is there any way, is there any mathematical way in which uh, in the beginning only or at before doing any of the moves, we can say whatever amount total amount is present in the network, by looking at that, can we say is it possible to come to a winning configuration or not? Or is it possible to distribute that money in such a way that our network becomes balanced, or everyone has a positive bank balance about positive or zero? So let us look at that now. Okay, so I will introduce the concept of genus over here. Okay, genus of a planar graph. So intuitively what genus does is, um, in very big graphs what can happen is we will have lots of edges. Okay, so edges, if edges are more, then what will happen? Genus tells us that when your edges are more, whether you can draw your graph on a plain sheet of paper such that none of the edges are crossing each other, or we can say if this graph is planar or not. If the value of genus is a higher number, uh, more than one, suppose let us see the formula first, that is edges minus vertices plus 1. So in any planar graph, what genus tells us is uh, how many upper layers you have to add, or more planes you have to add, or holes you have to add, so that the graph becomes planar. So what I want to say is, let us see an image. Uh, Suppose you have a road network. Okay, on a paper you made a road network. Okay, like this you made a road network. It's a K5 network. Okay, okay, let us try to understand this. Okay, you made on a piece of paper, this is your road network between points in the city. Okay, this is a K5. Now you want to understand, in order so that your road network does not have intersections, these edges are roads, and see these two edges are intersecting over here, and we know if road intersections are there, traffic jam, the if cars are more, flow of cars are more from more sides, then traffic jam can happen. So in order to prevent intersections of road, what the civil engineers they do, they make flyovers. So if they want to know how many flyovers, so flyover is like this road on the below side, this is a one plane, and another layer on the sky, one road is added, so that is the second layer. So how many flyovers or more layers you have to add in your plane, so that no edges are crossing each other or no traffic jam happens. Is this concept is similar to that? So the genus tells you that if the value of genus is 0, that means just one plane or one sheet is enough so that the edges are non-intersecting. Okay, if the value of genus is 1, then that means, I will show you, that means this is uh, okay, so this is the K5 graph. Now K5 graph, let us try to draw first on a plain sheet of paper and see the edges will, we can make it or not. Okay, this is your K5. Okay, I draw like this. Okay, now this I cannot draw over here, so I will have to draw like this, and one more edge from here to here. But see, now I have to make two more edges for this vertex, one, two, this third vertex. Okay, this third vertex, if I want to make it, join it like this, so it will cross this 1 4 edge, so that is not allowed. So on a plain sheet of paper I cannot do this, because if I make it, try to make it from outside, that also will intersect with this 2 4 edge. So what will I do? I will add a flyover layer. So I can make this graph planar on a surface like this donut. This is called a toroid. So what we did is, this edge and this edge is on this plane. Okay. Now the two more edges we are taking it from backside like this. Okay. So they are not intersecting now. And one more edge uh, is on the surface like this. Okay, surface like this, and they are joining, so none of the edges are intersecting, and this k5 becomes planar. So this is similar to the concept of making flyovers. Okay, see. mm, yeah, so this is similar. So the more complicated your graph is, you have to make more flyover layers, and that looks like this handle. On this sphere is the plain one single sheet of paper, and on it we have to add the flyover bridges like this. So the number, the value, higher the genus value, this is showing for genus 3. The more higher the genus value, the more layers of flyover you have to add, the more complicated is your connection of your network, so that to make simplify the network or make it planar. I hope you understood. Okay, so how this genus concept is connected with our dollar game, our distribution of the uh, money, or yeah, currency in our network. Okay, so the theorem says is that you need, in at any stage of the game, if you sum the total amount of money present on your board, uh, that should be greater than or equal to the genus value. Okay, amount on board total network. If you have minimum this much of total amount on your network before redistributing at any stage of the game, then only you can remove all the debt or traffic jam causing uh, debt causing nodes. Okay, so why? So one question might arise is, uh, see, only the amount of money which is present to remove everyone's debt is not sufficient. I can show you one example. Okay, this is one example. See, initially total amount of money is enough on the board to make everyone's debt zero. This has +1. If it gives to -1, then total amount present on this board, amount amount present on this board in the whole network would be +1 -1 0, right? It should be enough to make everyone's debt zero. But look, if we no matter how many moves you play on this board, you cannot make all the nodes positive or zero. We will show one move. This +1, it gives +1 and +1 to other nodes, and what happens? This becomes +1, this becomes -1, and this becomes 0. Okay, again you play one more move. We will send from here +1 and +1. What will happen? Okay, so this will become 0. No, sorry, -1. This will become -1. This will become 0. This will become +1. So in this board configuration, the connection is between the nodes is such that no matter how you distribute, how many moves you play, you can never make all the nodes positive or uh, zero, or you cannot remove the negative, the debt from this board. The amount of money is just not sufficient. Let's see what's the genus value of this board. Okay, the genus value of this board is the edges 1, 2, 3 minus vertices, that is 3, plus 1, that is 1. So minimum you need $1 on the board and the amount present was 0. So let us make $1 on this board. Okay, I'll change the amount over here from 1 to 2. Okay, now let us see we can make the depth 0 or not. Okay, so I'll erase parts from this. Now the amount present is 1. Okay, uh, the amount present is 1. Okay, okay, so from 2 we give plus 1 and plus 1, so this would become 0, this would become 0, and this would become 1. So we won the we won the game. Okay, so this genus value, the if the dollar amount of money present before redistributing is greater than equal to the genus, this is a necessary condition. That means if this uh, condition is violated at any stage, then you cannot make the board balanced. Okay, balanced means removing negative nodes. But if this is true, that is not sufficient to tell that you can make this graph balanced or not. Okay, okay, yes. So I will recap once again the dollar game for you. So in the dollar game, the most important thing to tell whether you can win the game or not, whether uh, tell win or not, whether you can win or not, two things are important. Number one, the amount present total network should be, first it should be positive. If there is not sufficient, if the total everyone has a debt, then obviously you cannot make redistribute the money and make remove the negative values. That cannot happen. Okay, first is this, and second is that the amount present total network, in the total network present in total network has to be greater than equal to the genus value. Genus value, it was telling how many flyovers you have to make or add additional layers to your plane so that your networks connections become simplified. Okay, and you are able, you will need minimum these many amount of money to ensure that negative depth nodes are removed from your network. Okay, and second point is only having numerically having the amount that can make everyone's depth 0 is not sufficient. The connections present between the players, how complicated they are, how complicated is also important, is also important to tell whether you can win or not. Okay, so I hope this you like this video, you understood something new, and in the next part we will discuss how dollar game is connected to balancing relationships in a social network. Okay, so stay tuned, keep thinking and trying new problems, and like, share and subscribe to my channel. Take care, bye bye.